Good day, everybody. I'm Mrs. Gitanjali Samir Mahmudkar from Dr. Babasaheb Ambedkar Technological University, Lunari, Maharashtra, India. I'm here to present my paper, my work on landslide prediction using multilayer perceptron model. So, as you all know, landslides are a crucial hazard, like natural hazards that can cause severe loss to not only the environment but property and lives too. So, it is necessary to, we can say, it is important to predict the occurrence of landslides due to so that we can avoid the damages that can be caused, or at least reduce the amount of damage that can be caused to property and lives. The occurrence of landslides is majorly influenced by the climatic changes, or that is the natural phenomena, or it could be natural reasons, or due to the anthropogenic factors like urbanization and deforestation. So, in various regions worldwide, machine learning algorithms have been used, and they have given good results in landslide prediction. So, in this study, we have used multilayer perceptron model after comparing its performance with other machine learning models for landslide prediction, and we have used the public domain dataset from the Muzaffarabad district of Pakistan. For this, I did a literature survey, especially to answer few questions like what is the significance, or what could be the significance of landslide as a geospatial task. As discussed earlier, it is for reducing the damage that can be caused due to landslides, and which are the landslide conditioning factors that can be used to determine landslide susceptibility. So, landslide conditioning factors are basically the factors contributing to the occurrence of landslides. So, I did a survey of this and found few of these factors, which is aspect, curvature, slope, flow, lithology, etc. These are something related to civil engineering things or geological aspects. Then, which machine learning or deep learning algorithms are most effective for the landslide prediction? So, basically, I did a survey and found few of the machine learning algorithms that majorly I used for this work, and I selected a few for the performance profiling. That is logistic regression, linear discriminant analysis, Gaussian knife base, support vector machine, and multilayer perceptron. The research objective behind this study was to apply different machine learning and deep learning algorithms on the landslide dataset for landslide prediction, then to do a performance profiling of these algorithms and come out with one of the best amongst these few and implement it for landslide prediction on the landslide dataset. The landslide dataset, as I said earlier, mentioned earlier, which has been used in this paper is from Muzaffarabad district of Pakistan, which is a landslide prone area. So 1213 different sites have been selected, and the parameters, like the 12 conditioning parameters that I mentioned earlier, values for them were taken, and a fuzzy gamma operator model has been applied by the author of the dataset to map the landslide susceptibility zone into 5 classes, like depending on how much does that factor contribute to landslide. Okay, so that is very high, moderate, low, or very low. And then depending on these values, the 13th column, that is whether an area is a landslide prone area or non-landslide area, that classification is done. For this implementation, I have used cloud infrastructure such as Google Colab and scikit-learn library, which actually, as you all know, Google Colab is a cloud-based development environment which has different machine learning and deep learning frameworks readily available. And then the scikit-learn library has got tools for data mining and analysis. So I've used them for the performance profiling, and because it reduces the requirement of high computation at the local machine, we can use the cloud infrastructure and focus on the analysis and interpret the results. So the methodology that has been followed is in this way. So Landslide dataset has been imported from the Kaggle infrastructure. Kaggle dataset. It is a Kaggle dataset where datasets are freely available for use, and it is an open dataset which I downloaded, and then data scaling was done using standardization so that we generalize the data points. Okay, because as the difference between the data points is lesser, it is very well, like it is easier to train the models more accurately. And then the data set was split into train and test in a ratio of 70-30, and then the machine learning algorithms using the scikit-learn framework were used: logistic regression, linear discriminant analysis, support vector machine, Gaussian naive Bayes, and multilayer perceptron. Then I calculated the accuracy of each of them, and they were compared on the basis of the accuracy parameters like accuracy, precision, recall, F1 score, etc. Sorry. These are the results that were obtained, and as you all can see, the test accuracy was the best in case of MLP classifier for this dataset, and hence I further implemented a model using this multilayer perceptron classifier, which actually has the input layer, the output layer, and one or more hidden layers. What it does is you take each node in a layer is connected to every other node in the subsequent layer using specific weight, and then the output that is generated is compared with the targeted output, and if there is any error, like more difference, then you adjust the weights accordingly to bring the output that you get closer to the targeted output using the activation function. Sorry. So from the results that we've obtained in this paper, the multilayer perceptron model gives the highest test accuracy. This is one of the conclusions that we came, and we've seen that the other were traditional machine learning algorithms, which require more of feature engineering, and as compared to them, data engineering is required less in case of deep learning. So we can conclude that deep learning models are more suitable for such classifications, or rather geospatial data analysis. Then further it can be used for landslide risk assessment for areas with similar environment conditions, and you can plan disaster management strategies accordingly to reduce the loss caused by landslides. Thank you.
Thank you very much. Do you have any questions? Yes, sir. Sorry, you raised your hands earlier. No? Okay. I'm so sorry. I thought you were raising your hand. Anyone would like to ask some questions? Oh, yes.
Yeah, thank you for this talk. Do you have example images how such data looks like? It would be very interesting.
No, not at this moment, but it is a CSV dataset, numerical dataset.
And the data in the CSV?
CSV format.
Yeah, but where does the data come from? How do you know if it's good or bad?
It's from Kaggle environment.
Okay,
I downloaded it. It is a public domain dataset, and
okay.
yes.
Okay, I will look at it. So interesting. Yeah, thank you.
So thank you.
Thank you. you.